Hi everyone, my name is Subhrajyoti Sen and I'm an Android engineer at Keep Trucking. And today I'll be talking to you about building a better code base with Lint. In this talk, I'll be exploring what Lint is, how do you come across it in a day-to-day usage, why exactly you should care about writing custom Lint rules. We'll also take a look at how exactly do you write a custom Lint rule, write fixes for those particular issues, write tests for the Lint checks, as well as a few tips on how you can start integrating custom lint rules into your project. So let's get started. Okay, first let's see what exactly lint is. It's a static analysis tool. So it can run checks on your code base without actually having to compile them. And this makes it pretty fast. It's also open source. So the lint checks that come out of the box with Android, as well as the lint API, all of it is open source. And I'll be attaching a link to all the default lint rules that come with Android at the end of the talk. It works on a variety of file formats, be it Java, Kotlin, Gradle, ProGuard, XML, and much more. It can be used outside Android as well. So if you're working on a non-Android Kotlin project, you can make use of lint rules there as well. The lint API is pretty extensible and you can extend it to write custom lint rules. And this is one of the main topics for this talk. You can run lint both from Android Studio as well as from the command line. So if you want to run lint checks on your continuous integration pipeline, you can do so. What does lint look like? I'm sure most of us would have come across lint at some point or the other while developing apps. So let's take a look at a few scenarios where lint kicks in. The one example I'm sure everyone has come across is using hard-coded strings in a text view. So if you look at this example, I'm using a hard-coded string, test string, and I get this tooltip telling me that I'm using a hard-coded string and I should rather be using a string resource. If you've worked with web views and had to enable JavaScript on the web view, you surely would have seen this warning where Lint tells you that enabling JavaScript can lead to vulnerabilities and hence you should review this carefully. Lint also has a check for a common performance issue where people end up allocating objects inside the on draw. And Lint gives you the suggestion here that instead of allocating objects inside your draw or layout operation, you should pre-allocate and reuse them instead. Another very useful case where Lint kicks in is for accessibility. So if you override only a subset of the methods needed for accessibility, Lint will warn you that you're missing out on a few overrides. In this case, I have overridden onTouch event, but Lint tells me that I have not overridden perform click. If you take a look at the tooltip, you will also see that it gives me an option of suppressing it by using the suppress lint annotation and a certain ID. We will see how to define this ID as well. Now, why should you consider lint or writing custom lint rules for your project? First would be having an opinionated code base. As we start working in a team, we tend to form certain opinions on how certain code should be it, for example, opening up curly braces on the same sentence or same line or going to the next line, or it could be more complex scenarios as well. If these opinions can be extracted and implemented as lint rules, it standardizes the process and also kind of automates your opinions, and who doesn't like automation? It also makes it easier for new members of your team to not have to try to remember all the standards they're supposed to follow or the project-based standards they're supposed to follow. In case they forget, Lint will remind them. It also leads to simpler code reviews. So if most of the common issues that can occur in your code base can be checked by Lint rules, it kind of takes away that responsibility from the reviewer, and the reviewer can rather focus on more important details in the code base, thus leading to a more enjoyable code review experience. And adherence to a style guide. Most of the apps you would have worked on would adhere to a style guide. which kind of represents the branding of the app and a few other factors. It could be colors, typography, shapes, and many other things. Again, it's both useful for both new members of the team as well as people who have been on the team for a long time. Sometimes you might be involved in resolving a very nasty bug and you might just forget to apply the right style or maybe use the correct component. Lint will remind you. Okay, so let's see how you can set up custom lint for your project. The first step is to create a new module. In this case, I have created a new module, a new Java module, and named it lint. You can name your module anything, be it lint rules, lint checks, anything that's descriptive enough. The next thing you need to do is include a few dependencies inside the build.gradle of the module you just created. Since I'll be writing the lint rules in Kotlin, I have included the Kotlin standard library. The important dependencies for this section are the lint API and the lint check dependencies. Since you'll also be writing test cases, you can include the lint tests as a test implementation for writing your unit tests. Now, before you start writing your lint rules, you need to create a registry, an issue registry. An issue registry is something like an index that has references to all the issues and lint checks you have declared across your module. So whenever you run the lint debug or a lint task from Gradle, Gradle knows where to look for to find different rules. In order to implement a registry, you extend issue registry. And the main concept here is that of the overridden issues. It has a type of list of issues. We'll be taking a look at the issue class shortly. And since at the moment we have not written any particular issues, we're returning an empty list. When we do write a lint rule, we'll come back and include it here. Now, once you have defined your issue registry, you need to register your issue registry. To do that, in the lint build.gradle, you declare a manifest attribute. The attribute name is lint registry v2, the version 2, and the value would be the class of a registry with the entire package name. Now you have created your lint module. You need to include that as a dependency to your main module. In this case, my main module is app. So I'm using the lint check function to include the lint module as a dependency. Before we go into the details of writing custom lint rules, there are three concepts you need to know about: scope, category, and severity. Let's take a look at scope first. Scope defines the kind of files that the lint rule is applicable to. Here are a few examples: Java file scope, Gradle, manifest, program, resource file. Going through the names, you can see that they are pretty self-explanatory, and this is on purpose. An interesting thing to note here is that the Java file scope is also applicable on Kotlin file scopes. And this is because both Java and Kotlin inherit from a universal abstract syntax tree, and the Java file scope works on that syntax tree, and hence it is applicable on both the language formats. Next is the severity. It defines how severe the particular issue detected by lint is. It could be informational or a warning, or it could also be an error. If it is an error, it will actually fail your lint task. You have an option of adding a Gradle flag to let your build pass even if it fails. And lastly, there is fatal, and this is reserved for issues that can have a very severe impact on your project, and you never want to, for example, merge code that has a fatal lint issue. The next is category, and it just defines the category the particular issue falls in from a predefined list of categories. Categories don't have a functional effect on your lint rules, but these come in handy when you're looking at the report file generated by Lint. So whenever you open the report file, it classifies the different errors that it came across, the different issues it came across, and groups them with the categories. So for example, if you're working on accessibility at a certain point of time for your app, and you want to see what the accessibility issues caught by Lint, you can open the report and just go to the accessibility section and then see all the issues there. Now let's take a look at a use case and then see how you can write the Lint rule for the same. Here, the use case is a style migration. So consider a scenario where in your app, you had a version 1 of particular styles. In this case, I have a style that's named v1.textview.header1. Now, certain changes are being implemented in your code base, and going forward, you want everyone to use version 2 of the corresponding styles. It would be very handy if there's a Lint rule for this. So whenever a developer starts writing code and they see or they start using the version 1 of the styles, Lint will just point out to them that this is an error. Don't do this. Rather, use version 2. So let's see how you can write the custom rule for the same. Remember how our issue registry had a list of issues? We would be creating one such issue now. To create an issue, you call the static method create on the issue class and pass a bunch of parameters. Let's go through them one by one. The first parameter is the ID of the issue. Remember when we took a look at the accessibility issue, it gave us an option of suppressing the lint check with a certain ID. This is the ID. It's a unique identifier that is used to refer to this particular issue and can be used to enable or disable this lint rule specifically. The second parameter is a brief description of what the issue is. In this case, the issue finds a v1 style usage and tells you to replace with v2. So it's a short description which gives the developer an idea of what's happening. If you want to give more context, you use the third parameter, which is a detailed explanation. So in this case, you mentioned that the v1 styles have been deprecated and you should use v2 styles for all text views going forward. The fourth is the category. Here, it's about correctness with adherence to a style guide, and we specify the correctness category. The fifth parameter is the priority, which ranges from 0 to 10, with 10 being the high, 1 to 10, with 10 being the highest. You don't really need to worry about priority at the moment. The next parameter is the severity, and we have mentioned it as an error because we want our tasks to fail if anyone has made such a usage. And lastly, we have to pass in an implementation. The implementation takes in two parameters. One is a reference to the detector class, which we'll be writing shortly. And the second parameter is the scope. Here we're using the resource file scope. If you think of it, we just want to look for usages of text view inside layouts. But the resource file scope looks like a very wide scope because inside resources, you can have values, which includes strings, colors. You can have separately styles. So we'll see how you can narrow down the scope later on. Let's see how you can create a detector. We have named a detector as v1 style usage detector. And since it has to pass through XML, we're using the resource XML detector. Depending upon the kind of files you want to pass through, you have different kinds of detectors available, and they give you different override methods to make it easy for you to write your rules. The first thing that we override is the get applicable elements, which returns a collection of strings. Here we want our detector to be applicable only on text view, so we return a list of text view. Now, there's a slight code smell here that we are hard coding the word text view. So instead, we should use a constant, and we get this from SDK constants. SDK constants is a huge collection of constants that define a lot of different elements, namespaces, and a bunch of other things that make it easier for you to write these rules and not hard code things. I once made a small typo in one of my elements and I had to spend considerable time figuring out why it wasn't working. So always use SDK constants. The next method is the applies to, and you get a folder type as a parameter. Here we can narrow down a scope like I mentioned earlier, and we return true only if the folder type is actually a layout folder. Again, we are using constants here. Now, when both the previous criteria are met, that inside a layout file, the detector finds a text view, it enters this method called visit element. Now, the visit element has two parameters, a context and an element. The context gives you information like the file name where the particular issue was found, the line number and the column number, and the element here is the text view. So first we check if the text view has a style applied to it. Then we get the attribute value. We check if the value starts with style @style /v1. If that's the case, we report this issue. We use the context to report the issue, and it has four parameters. First is the issue object we created earlier. Second is the element on where it's occurring. The third parameter is the location, and here we're using the context to get the location of the element. This will give information in the console about the particular line where the issue occurred, and it helps the developer quickly resolve it. And the last parameter is a short text that gives you some info when Lint reports this error. There's also an optional fifth parameter, which we will take a look at later. Now, after we have finished defining the issue as well as the detector, we come back to the registry and now register our particular issue. That's all you have to do to create a custom lint rule. Now, whenever you write a text view which uses a v1 style, you will get an error, both inside your IDE as well as if you run from the command line. Now, we are telling the developer what's wrong. Wouldn't it be better if you could give them a fix as well, that with one click, they're able to resolve it? This is where the lint fix API comes in. So what we do is we take the attribute value from the element. In this case, it's a simple string replace. So we replace v1 with v2. And then we start creating a lint fix. Here, our lint fix has two steps, and hence we create this composite lint fix. We also give it a name, replace v1 with v2, and this will show up in the tooltip whenever the user comes across this error and wants to replace it. In the first step, we create a lint fix that unsets the value of the style attribute. The first parameter is null here because this is the namespace. And you would have noticed that whenever we are adding attributes like ID, layout height, layout width, we use the Android namespace. But for style, we do not use an explicit namespace. And hence we pass null here. After we have removed that attribute from the element, in the next lint fix, we set that attribute with the new value of the style. So whenever the user comes across this error, they'll get an option to fix it. And remember, I mentioned a fifth parameter in the report API. The lint fix is the last parameter that you pass. It's optional. Now you have given the developer an option of fixing the lint issue. But if you've used other lint frameworks or libraries, you would have noticed that they give you an option of auto fixing it as well. For example, KTLint. It will tell you what issues are there, but if you call KTLint with the format parameter, it will actually try fixing whatever it can. Android Lint can do the same. All you have to do is add the autofix method at the end. And then if you call the lint fix gradle task, it will actually go on applying whatever lint autofixes it can. But once you run this, your build will still fail because the fixes are ran after the lint issues are found. So for the first time you run lint fix, it will fix the issues, but that particular task will fail. But if you run it again, it will pass because there is nothing more to fix. Let's take a look at testing. Remember, we included a dependency for testing explicitly, and the lint testing library gives us a lot of handy tools that let us write better tests. And you can run JUnit tests. You don't really need an emulator to run lint tests, luckily. So whenever you're writing these tests, you have to extend the lint detector test because you are testing your detector to see if they can actually, given a certain file or given a certain piece of code, can it find a lint issue or not? So the first thing that you need to override is the get issues method. It returns a list of issues, and here you can mention the issues just like we did in the registry. And the second is a get detector method, and here you have to pass in an instance of the detector you created. In this case, the v1 style usage detector. Okay, let's write a test case where we are using the correct style and hence we should not get any lint issues. We start out by using the lint method. Then we attach a files method to it. And the files method has pretty handy other methods that let you define static pieces of code. So you don't really need to define it in a certain file and then refer to them here and then write your tests, because those files might change anytime if they're part of your code base. And then you would have to keep adjusting your tests. So what the files API lets you do is mock out certain files and insert static code in them. So here I'm using the XML builder to create an XML file, but you have corresponding methods for Java, Kotlin, and a few other things. So here I am creating this file or emulating this file in the path resource layout XML, and then I'm defining this piece of code. You will notice that there is also syntax highlighting for the string I have written. And that's one of the great things about the Lint API, that it also lets you preview how your code would look normally in a file so that it's easier for you to write these checks. Now, here I've declared a text view, and it also uses the correct style, which is a v2 style. And then we run lint on this particular file. And as expected, there should not be any lint issues here. And hence we call expect clean. Now let's take a look at a test case where we actually have an inconsistency and then we write how to expect a certain error. So this file is also pretty identical to the previous one. The only difference here is for style, we are using a v1 text appearance, a v1 style instead of a v2 style. Now we run this code and we expect exactly one error because we have only one rule written here and then we have only one style attribute, which uses a v1 style attribute. So we call the method expected error count 1. If we had set the severity of an issue as a warning, we would be expecting a warning here. And we can also expect, or we can also specify what specific issue do we expect here. So we mentioned here that for the layout.xml file, on the first line, we'll get this error. With the string, replace v1 style with v2 with the ID of the lint rule that actually threw this error, and also some context about where the error occurred. So it tells us this occurred in the text view. And it also prints out that there was only one error and 0 warnings. Now, this might look a bit odd, like how do you come up with this expected string? The easiest way is just run lint normally, see the error thrown by lint, verify it, and if it makes sense and if that particular output is what you expected, you add it in the expect block. And this is one of the benefits of actually specifying the code inside the files instead of actually importing a different file. Because if that file changes, you'd have to keep changing this expected output as well. Coming to integration. Now, hopefully at this point, I've convinced you a bit that you start writing such lint rules for your project. So if you start enabling Lint and take it seriously, how exactly do you go about doing that in your code base, which I'm considering is considerably large at this point? One thing you can do is incremental fixes that with each release, ship out a few fixes at a time. And you can do this using a baseline. So let's see what a baseline is. To create a baseline, in your builder Gradle of the particular module where the lint issues can occur, we use the lint options constructor and specify this baseline file. In this case, lint-baseline.xml. You can name any file you want. If this file doesn't exist, Lint will create it for you. Now, we ran Lint debug on our project. And you can see that the Lint found one error. It wrote the reports to particular files. In the third line, it found one error and also specifies that it created a baseline file. That's like the fifth white line. Created baseline file in the file that we mentioned, that is lint baseline XML. Now, what this does is it takes all the errors that are in your current code base and writes a snapshot of that in your lint baseline. When you run lint the next time, lint will ignore all the errors that it comes across that are common with the baseline. So going forward, you can run lint baseline once, create the baseline, and then go on from there, that whenever someone introduces a new lint issue, they have to fix it. At some point, you can incrementally go exclude a few things from the baseline and start fixing them one by one. Now, if I run lint debug again, you can see that the output is lint found no errors or warnings, but it did find one error that was filtered out by the baseline. And the build passes because there are no new warnings. Let's take a look at how a baseline file would look. Here I had this issue called a missing style attribute. It gives me the ID message as well as an indicator of where or what element the error occurred on, as well as location details such as the file, column name, column number, and line number. And remember how I mentioned that you can use the context to get information about where the particular element was visited? This is the same example here. Talking of performance, lint rules can be classified in two ways, a single pass and a multi-pass rule. A single pass rule, for example, would be looking for missing attributes or finding certain attribute declarations. For example, the V1 versus V2 example. Now, single pass lint rules are pretty fast and they can be enabled in the IDE. So the example of the style migration lint rule that you saw, it is enabled in the IDE because it just does one pass. An example of a multi-pass would be unused resources. Here, lint would need multiple passes, first to make a list of all the resources and then see if there are any references to them. So it would need multiple passes to do that. And multi-pass lint rules are usually slow and they're disabled in the IDE. That's the reason you might have noticed that whenever you're committing code through the Android Studio, you get an option of find missing attributes, find unused resources, and a few other options. They're not enabled real-time in the IDE because if they were, you would get a lot of lag. And that's not something you want while typing your code. Since everyone's writing Kotlin these days, you need to make some Kotlin considerations. Some functions in Kotlin need not have an explicit return statement. So if you're writing a lint rule that specifically looks for the return keyword, you might not find it if it's a Kotlin file. There are no explicit type declarations. You can specify a variable A and assign 5 to it without ever mentioning explicitly the data type of that particular variable. In Java, you would. And as a rule of thumb, what you can do is whenever you're writing a lint rule, write a test case against a Java file as well. So the way we wrote the tests for the XML files here, you can use both Java and Kotlin constructors to declare files and then write lint rules on them. And whenever you're writing a test for a Kotlin file, try writing the Kotlin file how you normally would. Like, for example, you might not specify those explicit return types. You might just declare the method and directly return a certain object. A few references if you want to learn more about Lint. The first is the Google group on Lint. Lots of people ask quite interesting questions, some issues they face, so it's a pretty good place to know what the different kind of Lint rules people are writing. Second is a repository, which has examples to this talk, which will be updated later today. The third is a GitHub repository, which has a big collection of Lint rules. You can learn a lot from it. The fourth is a talk from CotlinConf that goes into much more depth about writing lint rules, especially for Kotlin. And like I mentioned, lastly is a link to all the checks that come with Android Studio by default or with Lint by default. There are more than 100 lint rules and you can learn a ton from it. And that's it from my side. If you ever want to discuss Lint or if you have any issues with Lint or you just want to discuss anything, that's my Twitter handle, so you can definitely reach out to me. If you have any questions, I'm open to taking them now. Okay. The first question is, do you think devs will still use XML files and old way design? Okay, I think this question is with respect to Compose. And yes, devs will continue using XML files, at least for the foreseeable future, because Compose is still in development. I don't think so. You are supposed to be using it in production, so you would continue writing XML files the old way. As far as, okay, the next question is, as far as I know, Lint doesn't have proper documentation. While you study Lint APIs, what do you use as a reference and could you share them? So the last slide that I mentioned has links to whatever I used to learn about Lint. I mostly learned them by looking at the different examples, but recently many people have started writing really good blog posts on Lint. And I primarily use the different examples mentioned by Android, and a bit of it was experimentation. That being said, I think there is work being done on the Lint documentation, and it is mentioned in a README inside the AOSP source code. I don't have a link to it, but I do remember coming across it. Someone from Google tweeted it, so it's a good place to get started. Okay, it looks like there are no more questions. If you do have any more questions, you can always reach out to me through Talk. I will be present throughout the day, so you can message me there. Or you could reach out to me on Twitter. I have my Twitter handle mentioned on the last slides. Okay. Thank you for coming to my talk, and I hope I was able to convince you to start using Lint.